plate. Oh, yay. I have to exit the play before I can move anything. Oh, they can't, it was on the TV, right? Oh, okay, well, we don't want to see it either. So we'll go back to this and we should be good. So the Varroa mite is kind of huge compared to the bee. Like we think about how terrible a tick is on us, but think about how small a tick is compared to our bodies. But this is like a giant tick. So poor creature. So if you look at the life cycle of the bee, you have an adult bee and you have rhetic mite on the bee. And that means it's traveling, it's not in the process of breeding. And mites can sense the pheromones that brood put out. So when a larval bee is mite is reproducing. So you have mated mite in the cell. She feeds off the hemolymph. She gives birth to a male and then gives birth to so the cycle of the mite to the life cycle of the, does that make sense? And that's kind of a lot of detail that you don't necessarily need to know, but the fact that from adults that new queen, if you need a new queen, you want her to emerge pretty quickly. But drones are 24 days. So they have 14 and a half days went into the cells with the drones. And if you lost a few drones, it wasn't really that important because you're just losing some of your mating material, and a lot of drones never even mate with the queen. So it wasn't a loss to the colony. But now, even though they prefer the drones, they'll go into any cell. So you have worker bees who are being affected by them. So this is just a chart. If you want to take a photograph of it or a screenshot of it, this is just kind of showing you the relationship between the drones, how many babies the mites will have in a drone cell versus how many they'll have in a worker cell, which is kind of important when you start to try to control your Varroa mite population. Does that make sense? Okay. So what happens, we've been talking seasonally, right? That like right now our bee populations are going through the roof. And since the queen is laying and there's so much larva, the mite population, which over the winter was kind of stable, is also going up. But then what happens in your colony is hit the summer dearth, right? And the bee population starts dropping, but the mite population is still going up. So when the mite population goes up above the level of the bee population, that's when you start seeing serious losses. So you need to be aware of what your mite percentage is in your hive throughout the year. But as you head into like late summer, early fall, that's the critical time that you need to make sure that you knock that mite population back down. And we're going to talk about different ways to do that. So if you're in your hive, pretty much if you have a beehive, you have Varroa mite. But if you're in a hive and like the bees aren't performing, you're like, they're not bringing in as much food as you think they should be. They're just like, you know, they don't look really healthy. There's not a lot of good activity. It's probably Varroa mites. You can occasionally see a Varroa mite on a bee. As you can see in this picture, you can see there are 2 mites attached to the back of this bee. And this bee has a disease that's carried and amplified by the Varroa mites. It's called Deform wing virus. So see how our little wings are all crinkled up? Pretty much if you're seeing deformed wing virus in your hive, your mite population is probably out of control and it's probably too late for this hive. Maybe not. You might be able to bring it back down, but it's not something you want to see. So you want to monitor your Varroa mite levels. So you start, best ways to do it is a sugar shake. There's a couple others. Walter uses alcohol wash, which is the same technique, but he uses alcohol instead of sugar, which means that he's killing his sample of bees. It's probably a little more accurate, but with the sugar shake, you don't need to kill the bees. So you take a nice mason jar, you get a lid with a screen on top of it, you tip your frame back. This is one of our wonderful bee inspectors doing this, and you kind of tickle the jar across the frame. The bees fall into the jar, and what you want is 300 bees. And there's a method for figuring that out. You can measure a set amount of water, and make a mark on the jar. And if you that many bees, they've figured out that many bees equals that much amount of water. Takes up the same amount of space. You can see the line that we've drawn on the side of this jar. You can see peanut butter jars. We've cut the lid out. We've put a piece of screen in there. We filled it with like XXX powdered sugar. And so you stick the bees in there, you shake them a lot, like not in a violent way, but just enough that they get covered with powdered sugar. And what happens is the powdered sugar makes them slippery and the Varroa mites fall off of the bees. So then you tip your sugar shake jar over and you shake it and the mites will fall out. And it's good to have a white surface. It's often nice to we usually put a little water in like the lid of a 5-gallon jar, which is what that image shows. So you shake it out and then you count the mites. And so you've got approximately 300 bees, count how many mites you have, and that's going to allow you to calculate the average amount of Varroa mites per your entire hive. So these are simple figures, but you definitely want to stay under 10% in the hive. So if you have 3 mites per 300 bees, you're right at that threshold level. In the summertime, you could go a little higher because the bee population is higher, but anytime you have if you can shake more than 9 mites off your 300 bees, you have got to do something right then. Like that's crossing the threshold. So definitely 10% is what we're hoping for, is staying at or under 10% mites per bees. So, but basically more than 9 mites, if you shake 6 mites off, you probably want to do something. If you shake 9 mites off, you need to treat your bees right away. And I usually try to do a sugar shake kind of spring just to kind of get a feel for where my colony is, but then definitely later on in the summer. A lot of the treatments are temperature sensitive, so you can't do them like if the temperature is over 90 degrees. So you kind of have to time your treatments. So you want to know where you are and when you're going to treat. So if you have a bee that, an individual bee that has been on by a Varroa mite, what you're going to see is you're going to weight loss. You're going to see that they have shorter lifespans and then reduced learning skills. Now, we're studying bees to see the effects of pesticides, and we're looking at not instant death, but we're looking at a colony not doing as well. We are looking at these very things. We're not necessarily weighing individual bees, but we're looking at the lifespan of the bees. We're looking at the productivity. And one of the things the bees need to do is they need to be able to figure out how to go from the hive out to flowers, forage, and find their way back. And because the bees that are damaged by Varroa mites have reduced learning skills, that means you lose more foragers and you bring in less food. So a hive that we would say was weak on stores is probably being affected by Varroa mites. So then the other thing that they do is they vector and amplify. So just like the way that when a tick bites us, we can get a tick-borne disease, Varroa mites are hopping between cells and spreading diseases in the hive. And so there's a number of them, the acute bee paralysis virus, and that's a complex of numerous diseases. At this point. So treating Varroa mites, monitoring for Varroa mites is your number one job as a beekeeper. And if you don't do this, your hives are going to die. And that's just, it's sad because if you look at the time when my grandfather was a beekeeper, like he kind of got out of bees at the time, like 2 or 3 years after Varroa mites came in. But when he was a beekeeper, it was easy. Like, you know, there were very few things that really killed off your hive. You would have diseases, but usually it was very rare to like have a hive just die. And if your hive died, you could go out in the woods and find feral colonies in trees, cut them down and bring them home. And now feral colonies don't survive because they don't receive any treatment unless they're super isolated. They talk about some places that are extremely isolated where they found feral colonies that are very, very far apart, where Varroa mites aren't jumping between the colonies and those bees are surviving. But basically, if they're somewhere where they're exposed and the phoretic mites are hanging on to the bodies of the bees. So if they're on a drone bee and a drone bee goes from your hive, and drone bees are welcome anywhere, so they go to the hive down the block, then the mites spread to that hive. So they're very virulent. So what do we do? So monitor your threshold levels. That's the thing. You got to know what you got going on in the colony to know what you need to do. Practice Ipm strategies. And we're going to look at some Ipm strategies. There's some new treatments that are like they evaporate in the hive and they fill up and the bees breathe them and the mites breathe them. And they're really good. One is formed, which is the same thing that when you get fire ants that makes you hurt. And one is like thymol essential oils. It's made basically from thyme. And those are organic treatments. Two new treatments that are out on the market is Apivar, which is also called Amitraz, and oxalic acid. Oxalic acid you use only during non-brood times. So you would basically fumigate your hive in the winter time when your queen is laying. So we used to treat with these two things, Coumaphos and fluvalinate. They were both pesticides that were on the market before Varroa mites came around and were repurposed because bee the bee came, the mites became resistant to these chemicals. And when you test your wax for chemicals, these are the two main chemicals you're going to find in your beeswax. So, and what happens is the Coumaphos and the fluvalinate stick to the wax, and then other pesticides join with those and have this like cumulative effect. They interact with each other. And so when you talk about bees being by pesticides, a lot of the time it's a combination of Coumaphos, fluvalinate, and other pesticides that by themselves are not that harmful to bees. So these discontinued treatments, I mean, I think they're still available, but you would not really want to use them. So one of the things you can do in your attempts to reduce your Varroa mite load is have VSH, Varroa sensitive hygienic bees, or bees that just have hygienic behaviors. And these bees have been bred so that they clean out, like they sense that there are larvae that are not doing well, and they'll open the caps and they'll clean those bees out. And they'll take them and they'll remove them from the hive. And in the process, they're going to remove the Varroa mites. They're going to stop the breeding process. And Varroa sensitive bees are bees that actually smell the Varroa mite, open up cells that have Varroa mites in and pull those larvae out and remove them. So that's a great thing. But since bees breed in the wild, right? We've talked about this whole breeding process. If you buy a VSH bee, her daughter's next queen in line is going to breed with these drones, and you're probably going to lose a lot of those behaviors. Mm-hmm. So it's very hard. It's not like that you can cross her, you know, all of your queens back in so that you maintain that quality. But they're definitely working on it. There's a lot of research being done, and there's a lot of great science going around on about and there's no brood, and then therefore the Varroa mites population will drop because they're not going to reproduce unless they have brood to reproduce in. When you have a swarm, that also causes a break in brood. You don't necessarily want a swarm, but it's a benefit of having a swarm. Some people will catch the queen and remove her cage so she can't lay for 2, and then return her back into it's kind of an invasive process. It gives you the same effect, this break in brood that allows the Varroa mite, like if your Varroa mite population is climbing, this gives you a break where the population will drop a little bit and you can try to maintain that 10% level. The other thing you can do is, since Varroa mites would much rather be on brood, is you can put in a special frame that's got larger cells in it. And when the bees draw it out, they'll only lay drones in it. So that's an example in this image of a drone brood. And you can tell it's a drone brood, right? Because it's got the caps are not flat like regular brood, they're bumped up on top. So you put this in your thing, they lay the eggs, tons of Varroa mites go into those drone cells because that's where they would really like to be, because like 14 days, right, to reproduce. And then you keep close watch on the time, and before the drones emerge, you pull that frame out, you stick it in your freezer, freeze it overnight, kills the drones, kills the Varroa mites, stick it back in the hive. The bees will clean out all and they'll relay it. And you will have like drawn and captured a large percentage of your Varroa mite population and killed it. Now, if you forget, right, you put it in and 14 days later, you don't pull it out, what it's going to do is it's going to hatch out and release a ton of Varroa mites. So it's like a thing where you've really got to keep good records to make sure you stay on top. But it's a really nice method of dropping your population. And you can do it anytime because you're not using any kind of pesticides. So anytime they're laying, that the queen is laying, you can do this method to drop your threshold. So I have just 2 IPM charts that I pulled off the internet, and I thought it's funny because they're backwards from each other. And so IPM is a way of look at pesticide use. Instead of us looking at them and saying, oh, this problem with this looper counter, right, on our crop, spray it with this chemical. IPM looks at it and says, what can we do before we get to that place to prevent it? So you start with like cultural things. So you pick a spot where you don't have a neighbor that has raging Varroa mites, right, within, a mile of your house. You get hygienic bees if you can. You can do physical or mechanical things like the drone brood removal, breaks in brood. If you put in screen bottom boards, which seems like kind of a silly thing, some of the mites will fall off the bees and fall out of the hive. So it's a really minor thing, but it actually reduces your population. So right now, there's no biological thing that you can do. Sometimes, like if you have mosquitoes, you can put Thorogenses in your floats, right, in your pools. And it's an organic, it's like the natural enemy of the mosquito larva. So, but there's nothing right now in that way. And then when you look at chemicals, and they use this interesting term, biorational pesticides, which is kind of organic. It means they're from natural sources. Doesn't necessarily mean they're not dangerous ever, but they're probably better environmentally. So, and then conventional pesticides. So you see that the Ipm, the amatraz, which I do use in my hive, is considered a conventional pesticide. But the formic acid and the thymol are considered biorational. And if you kept certified naturally grown bees, you would only use formic acid and thymol. So here's another chart, and it just kind of shows it in a different way. I think it's really nice because it kind of shows you the difference between the hard and the soft. So you want to stay at prevention. Like you want to stay ahead of it so that you have to use the least amount of pesticide. It's not that we don't use pesticides, but we want to reduce that to the largest degree that we can while still maintaining our Varroa mite population. And I think that's all. They're listing hop guard. I haven't heard really great things about guard. All of these are available at Bailey Bee Supply. A lot of the information I pulled off of NC State website, which probably has more updated information than most of my information is pretty recent, but it's always a good thing to look for when you're trying to make those decisions, because they are hard decisions. You're like weighing the lives of your bees against using pesticides that you don't necessarily want to introduce. So everybody kind of has to figure out where they fall on that spectrum, and it's definitely a learning curve. But if you monitor, that's great. Just the bottom line, with all pesticides, the label is the law. You have to read the label, the full label, and you have to follow it. So even the thymol and the formic acid are going to ask you to wear PPEs, protective equipment. It's harmful to breathe those fumes. They usually have some kind of mask system they want you to wear, which maybe I don't wear, but the label is the law. You need to read it and follow it. Especially with the more conventional pesticides, you want to be really careful with those. So, Varroa mites, any questions? Yes. They don't attack the queen. I mean, I guess one could get in a queen cell and do the same thing, but they're really attracted to the drone brood. So I think that's kind of unlikely. And if it was, if one, that queen would be eliminated, because there's usually multiple queens. So the bees wouldn't let that queen be the queen of the hive. They would make sure she was killed, and that another queen that wasn't affected. But, if you're talking about 50,000 worker bees, and say 10% of them are underweight, their lifespan has been shortened, they only live 6 weeks. Even if their lifespan is only shortened by a few days, that's a huge loss in the amount of honey and pollen that they can bring into the hive. So the effect, the cumulative effect on the whole hive is heavy. All right, I'm going to go on. What's the main thing you got to do? Monitor your levels. Sugar shakes. And Adrian, we can definitely get someone from the apicultural center to come out during the summer and do sugar shakes on the hives and walk you guys through that, because it's good to have someone with a lot of experience doing it, so you can see how it's done. Like, oh yeah. And Walter should be good we'll just volunteer Walter right now while he's not here to defend himself. And he does alcohol shakes. And so, yeah, definitely monitoring. And the bees that you got definitely had some Varroa mites. You're not going to get a package of bees without some Varroa mites thrown in. So I'm going to talk about some other diseases just kind of quickly. But I love this image. So this is what you want. When you pull a frame out of your pattern, you can see the next arch is all, and then the outer edges are capped honey. So when you pull a frame out, that's what you want it to look like. Means she's doing well and the colony's doing well. There are plenty of stores. There's a good laying pattern. And when you look in the cells, this is what you want. Like white, pearly larva, really healthy, lovely cappings on the capped frames. That's like beauty right there. So what you don't want is this. So you can see laying pattern is really, really spotty. It looks like she laid here and then laid over there and then laid over there. And then if you can look, the cappings are a little sunk. And usually sunken cappings are a sign that there's something wrong in the cell because they're dropping down. You don't have a lot of bees on this frame. This is like, if you see this, I call your inspector and say, please come and look at my hives. It doesn't look right. So the first disease, and this is a lethal disease, but it's very rare. And it's mostly very rare because we have great inspectors and they help monitor for it and take care of hives that have it. So it's extremely contagious. So if your neighbor gets it, the chance of getting it are very high. So what happens is that the foul brood into the hive, and it's a bacterium, and it basically dissolves the larval bee. And it attacks the bees, the larval bees, when they're pretty late in their development. Proboscis. So what you're seeing in that bottom cell, like the one on the, I don't know if that's on your, yeah, that would be on your left. Right in the middle, you see this thing sticking up. That's the proboscis of the bee. So they've dissolved everything but the proboscis, and it sticks to the bottom of the cell. So you get this shiny scale, and that's what was the bee's tongue. The other thing is if you open the hive in foul odor, that's why it's called foul brood. Your hive will have this really icky smell. Now, the confusing thing about this is if you open your fall and your bees have been foraging on this, your hive is going to have a weird smell. Like when they process aster honey, once it's processed, it doesn't smell bad, but during the time when they're drying that honey out, it's going to give a weird odor. So the first time you open your hive in like September, October, you're going to get the smell and you're, my goodness, it's foul brood, but it's probably just aster. But if you open your hive and you see like poor laying, you sunken caps, then you need to like kind of assume it's foul brood and you need to call your inspector. And that'll be the thing I'm going to repeat over and over again. The inspectors are there to help you. You can talk to them over the phone. You can email them pictures. They will come to your hive and look at your bee. So the other way to do this, so in this picture, it straight on, but if you're trying to see if it's got those scales on the bottom, you want to put the sun at your back and you want to hold the frame at an angle and look down so you're seeing the underside of the cell. And that'll help you see that proboscis and help you identify it. But if you call your inspector, they will look for you and see it. Okay, this is what happens. So if you have foul brood, contact your local inspector, and they're just going to tell you to burn all of your equipment because there are hundreds of millions of these little cells that are going to become more foul brood. Like you just can't get rid of them unless you irradiate them. Now, we have this great ethylene oxide chamber. It's at NC State. It breaks down fairly often. So it takes some time to get your hives irradiated. It was used for moon rocks. When we first went to the moon and we wanted to make sure that we weren't bringing anything back to Earth. So what you do is you take everything out of your hive. So there's no bees, you kill your bees, you clean your hives out, and they put the woodenware in this box and irradiate it, and then that kills the foul brood. So it's kind of a cool thing. I've never had to do it, but yes. Say that again. You can hose them down with the water. Works fine. You could just lay out your frames overnight if it's cold, and that would kill them. I'm trying to think. Soapy water is the main thing I've heard the inspectors say that they've done. And like I said, I've never had to do it, but the inspector will like walk you through the process and help you. That's why we only have a 3% occurrence of this disease, is because the inspectors, that is their primary purpose, is to prevent the spread. So they'll come out and talk to you about it and confirm if that's what it is, and then help you take care of the problem. So European foul brood versus American foul brood is not really that bad. It's not as dangerous. So you can see in this image, there's a little bit of sunken caps. We're not seeing that goops. The larvae are attacked at an earlier age, and they're not completely dissolved. So you don't end up with that goopy, resinous kind of substance. You're seeing larvae at lots of different ages that have kind of turned brown. Some have been uncapped. Some haven't even reached the state of being capped. And see, that looks very different, right? But you don't need to worry. If it smells like foul brood and you don't think it's asters, the inspectors will come out and, oh, this is just European foul brood and it's okay. So what you want to do is you want to make sure that your hive tool is clean. I probably haven't stressed this enough, but anytime you use your hive tool in a hive, it gets honey on it, it gets wax on it, it gets propolis on it, and any diseases will collect on it. So I like to stick my hive tool in my smoker and just burn everything off of it before I use it. I use it to poke my smoker, to push down the material in the smoker to get the smoker going really well. But clean it. Lots of people scrub them, take them to their kitchen sink and scrub them. Don says you should feel comfortable eating off your hive tool. So if you feel like you can eat off of it, then you're probably doing good. If you have European brood, you probably want to replace your queen, because that'll help, because it'll change your population. If you have a generation of bees that are susceptible to American foul brood, if you put a new queen in, the new bees that she lays will probably be more resistant. So some of that's genetics. So requeening, kind of all the books are like, if you have this problem, requeen. If you have this problem, requeen. So it's kind of, you're going to hear it a lot, but it is a good, it's a good tool if there are queens available. So there's Nosema apis, and now there's Nosema ceranae. This is just, it gets in the gut, the mid gut of the bees, and it basically gives them dysentery. And so if you have Nosema apis, what you'll see is this speckling on the front of your hive. These are bees who are basically have diarrhea, and when they're flying, it just lands on the hive. So it's fairly common, but a lot of the treatments that we do to treat Varroa prevent it. Nosema ceranae is just a slight variation, and it doesn't have any recognizable signs. The only thing you would see is like your colony would not be doing well. It wouldn't have good stores. The population wouldn't be good. It wouldn't be really active. So nutrition is part of it. So feeding your bees, requeening would help. I have seen this maybe once in my years as a beekeeper. I don't think it's as common as it used to be. It's good to be aware of. I think that there are some elements with weather that influence outbreaks of it. Propolis, having bees that produce good propolis is going to help prevent this. The studies that state this is one of the diseases that they introduced to look at how propolis helps with resistance. So sometimes when you see a disease like this, what you're really seeing is Varroa mites, right? Varroa mites have weakened the bees, allowing other things. You're kind of seeing the end results, the symptom, but not really the cause. So tracheal mites are sort of in the same category. We used to have a really big problem with them. They live in the airways of the bees, and you can't tell by looking at them. You basically take a section between their head and their thorax and sample them and then put them under a microscope. There's some great micrology workshops at some of the state meetings that are really fun. And they always have you do the dissection to look for the tracheas. But the good news is the treatments we're using for Varroa mites are really the tracheal mites. So if you're taking care of your Varroa mites, you'll probably never have to worry about tracheal mites. It's good to know that they're there, but it used to be a major problem, but now it's not. Okay, chalk brood is this fungal disease the bees get. It happens during weird weather, like changes in temperature and really moist. Having a ventilated hive with a screen bottom board and maybe a ventilation, having the ventilation open in the top of your hive will help with chalk brood. It usually only happens to like one generation of bees. So usually the bees will recover. You might want to give them a little extra help while they're recovering. And what happens is the larvae become mummified. And if you shake a frame that has this rattly sound, and you'll see these little white mummified bees. It's sad. It's nobody wants to see bees die, but it's not a serious disease. So once again, you can if you have hygienic bees, less likelihood of this because they're cleaning the infected bees out, prevent it spreading, and then ventilating your hive, which I recommend for everybody in North Carolina with our humidity and our damp winters. Having a screen bottom board is going to make a huge So they can do extensive damage. If you're on top of monitoring your hive, you shouldn't have them with them. They especially are a problem. Store your frames, like you have frames, nicely drawn wax frames, and you store them enclosed in a dark space. The wax moths are going to get in and lay, and the larvae are going to eat up the wax, and then your beautiful wax frames that you want to put back on your hive in the springtime are going to be ruined. So it's define them, but usually you're only in an active hive if that hive is not doing well. So make sure your hives are strong. Don't be excess space. Like if you put extra frames on during the honey flow, make sure you pull those extra frames off so that the bees have less space to defend. If they can defend the amount of space, you're and and you see the Varroa, and you see the wax moths, it's probably a hive that's dying, probably because of have hive beetles, it's probably because you have a weak hive. Beetles, I might see one or two hive beetles in my hives, but most of the time the bees kindle the hive beetles. So lots of people set beetle traps, but sometimes the beetle traps will actually attract more beetles to your hive. They did a great study, which was really interesting because they had to figure out how to watch these beetles and see what they were monitoring. But what they found is that the beetles can smell a weak hive. So when the hive isn't doing well, the pheromone changes. And so a beetle could be flying a half a mile away and they can smell a weakened hive. Pretty incredible. So, and just think about how fascinating the research is that you have this little tiny beetle and you're trying to put this scent out and test whether it'll go this way or that way. Just people that study bees, they have so much fun. So the beetles get up in your hive. They lay the larva on the frames. The larva actually pupates in the ground underneath. And there's been some studies about soil treatments, things that you could add to the soil, like biological treatments to treat the larva. But I think the main thing is no excess space. You have a strong hive. Don't put it in shade, like don't put it way back under the trees like that. This is what happens. This is a picture of a hive that has been dissolved by hive beetle larva. Like it just liquefied everything. They eat everything in the hive. So they eat the larva, they eat the wax, they eat the honey, and they just melt it into this. And people I knew, a few who had hives towards the coast, they're really bad infestation that. But it's doing a lot better. But if you notice that in your particular bee yard, you're having higher numbers of hive beetles than you want, you can buy beetle traps. And they're basically like just these sticky traps that the beetles fall into. And you just have to monitor them fairly often. And, but usually if you're seeing a hive beetle problem, it's because your hive has another problem. And that problem is Varroa, right? That's the main thing. Varroa, Varroa, Varroa. So just, monitor for Varroa, treat it as you need to. Just be aware of what's going on with research. They're coming out with new treatments all the time. And call your inspector or call me, call Walter, and we will try to help. And don't panic. I know this is my worst talk of the whole class, but it'll be okay. All right, guys, any questions? So we've got one more class where we're going to talk about seasonal beekeeping, and we're going to kind of recap everything that we've learned so far. And then we have a class scheduled after that for asking questions and stuff, but I think we'll see if people want to have that class. We don't have anything really planned, but it's just so if we get to the end and you're just like, oh my gosh, there's 6 million things that we talked about that I don't know. But next class, we'll kind of review how everything fits into the year. So we'll combine all the different things that we'll learn, and we'll kind of look at the overall picture and what a beekeeper should be doing at any given point. And Oh, that's great. Good, good. Oh, that's great. Great. This is so exciting. I thank you guys so much, and I'm sorry for the unpleasant subject this time. We got our fun plant talk last time. Now we had to. Anyway, thanks, and I'll see you guys next